I'll quickly share my screen. We have YouTube session you have to start, right?
Started, sir.
Started? Okay. So welcome to OFCM 2022 G4 participants. Welcome for session 4. Session 5, rather it's session 5 today. And of course, I congratulate all of you who have come. It shows your dedication. Yeah. Today is, all of you know, right? Tomorrow is Deepavali, but still you have managed to take your time, okay, and spend for it. Excellent. So let's start the session with the Deepavali celebration. Yeah, right, fine. So let's start with the revision. Okay. Let's go for the definition of bounded above. Okay, don't worry. If you don't know, do not worry. So just what is fixed? A subset of R is fixed. A is fixed. Fix A subset of R. Okay. Now what is the definition of when do I say A is bounded above? A is bounded above in R if. See, this is a definition. Now I have to say if and I have to define. Do not worry about quantifiers and all. Just have an idea, as Balakumar was telling before. Okay. What you should think of real line. What should happen for you? What should happen if I have a real line? See, when I say A is bounded above, then it promises that I can find at least one lower bound. That's all. Do not worry about any other ideas. I can find at least one lower bound. That's the thing. Okay. Is that understood? Quick response. See, go by idea. Do not manipulate with symbols. Just go by an idea. Whenever I say A is bounded above in R, then this statement promises that I can find a real number which serves as a lower bound for A. Is that understood? Still, I could see few, but today I have to see how many participants. 61. Okay. R9. Soumika, Shah, Akshara, Rubendran. R8. Latifa. Please respond. Very good. Somebody is saying there is a problem for them. Who is that? Come. I want all of you to respond. Rubendran.
Sir, I can't understand the question, sir. Can you please repeat this, sir?
No question. I have not asked any question at all. I have asked whether you have understood what I have said. What is the meaning of A being bounded above in R? So can you tell what is the meaning when A is bounded above in R? Rubendran.
Sir, we can find an element alpha which is greater than the set Yang, sir.
That's what you are a bit confused, no? That's what, to clear the confusion, I said something now. But you have not listened. Did you join later?
Sir, no, sir. Signal problem,
okay,
sir.
Okay. So what I said is, I said the meaning for bounded above. Do not worry about quantifiers and all. First, what does this statement says? Look at the idea. It says, A is a set, it's fixed. I'm telling it's bounded above. That means what? The statement promises that I can find a lower bound for A. It says I can find a lower bound for A. Is that okay? Do you understand this? No, do not ask. Have you understood? Have you understood this?
No, sir.
Pedran?
Sir, no, sir.
Okay, you wait for some time. We will not spend time with you. You take
Yes,
it to your discussion hour. You can come back to me and also call, ask me. Okay, right. So you can, how about I'm going to ask someone, but it's not a question. So Angeline, Christy, have you understood?
Yes, sir.
Now
sir.
can you tell what should I write now?
A
Just
is bounded above in
yeah.
direction.
Ah.
Direction. Alpha belongs to R.
Now yesterday I used beta. I'll keep same notation. Beta belongs to R.
Beta belongs to R.
With what condition?
Yeah.
All of you are
For
going
all-
for the second one. That's why you are having a problem. Just tell the English thing, direct idea thing. I can find a beta because the statement promises that I can find a lower bound. There exists beta in R. So what should be beta?
For all X belongs
No,
to
I don't want that. See, again, you are going for the second one.
Beta
Is a lower.
lower.
See, step by step, try to process. Yesterday itself, I said, because it has two quantifiers, if you process both of them at the same time, you are having a problem.
Upper bound of A.
No, yeah, very good. So I have to change it to alpha, right? I was confused with that. Yeah, very good. Thank you. Very good. So bounded above. Because in the discussion just before we were discussing. Okay, bounded below. Okay. So here also I should change it to alpha. Right. Good. Alpha is upper bound. Okay, I am clearing all your feedback. Okay. Right. Now let's go for another statement. I don't want any negation and all. Okay. And even I don't want to expand. This is the basic idea. We have just seen what is the meaning of alpha is upper bound of A, and we have written here. Don't process these two things at the same time initially. Okay, at least for the first time, just have an idea, go step by step, then break it. Okay, there exists alpha in R, you can break it. Is the point clear? Alpha is upper bound for A. I know the definition. Therefore, I'm going to write it as a second step. Maybe we'll do that also. A is bounded above in R if there exists alpha in R with what property? Here I will expand. What is the meaning of saying alpha is upper bound of A? So real line picture. Alpha should be here. Members of A should be to the left of alpha. Also, it could be equal to alpha. So what should I write here? For all X in A, X less than or equal to alpha. That's the property. Okay, and this is the definition, alpha being upper bound of A. So do not directly answer like this. Okay, this is of course right. Both are right. Better, easier thing is this. This captures the idea. Okay, let me ask a question to you. Okay, let's collect this set. A set of all X in R such that X less than 1. Okay, now my question is this set bounded above? What is my question? Is the set bounded above? Quick. You have to little push. You have given the definition. Now you look at whether you can apply. See the first idea. Do not go for this set. The second one. It explains only. But this is the idea. So A is given to me already. Only question is, can I find a upper bound for A? That's the question. Right? Go by this. Is there a upper bound? That's what you have to ask. That's the first step. But why so many people are not answering? R1 Ritu. What was your problem? R1 Ritu.
Sir,
What's your problem?
sir, I didn't understand this, sir.
Is this set bounded above?
Sir, I don't know, sir.
You don't know. Why? What is the problem?
I didn't understand this, sir.
Okay. Do you know how to draw this set? Picture in real line. Where the elements are of A will be. I am drawing a line for you. What should I mark to understand this set? Ritu, you have to tell.
Sir, positive 0 and negative integers, sir.
Integers. Come on, look at this set. You are not concentrating. I have collected all. Can you give an element of this set? Give me an element of A. In fact, I'm clearing this to all of you. Let's clear. All of you be ready with an element of A. Can you give an element of A?
Sir, 1/2.
Very good. 1/2, right? So now can you, good. So, but why class response is very less? Think of other elements. 1/2 is there in the set. All of you think of other elements in the set. In fact, how do you describe this set in a real line? Ritu, can you explain now?
So yes, sir, all values be less than 1.
Okay. So if I mark it with this thing, so all of the numbers less than 1 is going to be there. Correct? Strictly less than 1. Yes or no?
Yes, sir.
All right. Now I'm asking the question. This is the set. All real numbers less than 1. Whether -5 belongs to the set A?
Yes, sir.
Very good. So you have understood the set A. Now I'm asking, is there an upper bound for this set? What is upper bound? This is
The maximum value a set has.
Right. No, don't say maximum value and all. Alpha is an upper bound if this condition is satisfied. Okay. Given any element of the set, it has to be less than or equal to alpha, right? Then I will say alpha is the upper bound of A. Correct? Have you understood this? Alpha is upper bound for A means what? Given any element of A, it will be less than or equal to alpha, right? Now I am picking an element of A. That means what should I do? Pick an element in the red thing. Okay. This is my say X. Now can you say a real number alpha such that X is less than or equal to alpha? This I should do for another thing also. Okay. Anything I pick, I should say. Now concentrate on this X. Can you get a real number such that X is less than or equal to alpha? Can you think of an alpha? Quick. Ritu, quick. Okay. I think, Ritu, what's your answer? Quick.
Sir, upper bound, it's not equal to 1, sir, so it doesn't exist.
There is a problem. We said less than or already we have taught you, right? See, this shows you have not recorded things properly. So what is the connection between X and 1? You tell that. X is less than 1, right? Ritu?
Yes, sir. Yes, sir.
Okay. So X less than 1 is true. Is X less than or equal to 1 true?
No, sir.
Why?
We cannot consider 1 in this set.
What is the meaning of X less than or equal to 1?
1 is included in the set.
No, I think you have to go back to the discussion hour. Ask questions to your friends. Already we have done this. X less than or equal to 1. What is the meaning? X less than 1. It's made up of two statements. X less than 1 or X equal to 1. That's the meaning. Okay. If one of them is true, then the statement will be true. So if X less than 1 is true, then X less than or equal to 1 is true. Okay. Right. Go back. Discuss this during discussion hour. So, Ritu, anyway, if you don't understand, doesn't matter. I'm going to ask someone else. Yeah, let me ask R5. Lekashri. Can you give an upper bound for this set? Quick.
1, sir.
1. Very good. Can you think of another upper bound for this set?
2, sir.
2. Okay. Can you give all the upper bounds for this set? 2, 3, 4, 5. It's okay. Now?
Greater than 1, sir.
Any real number greater than or equal to 1. 1 is also an upper bound. Any real number greater than or equal to 1 is an upper bound. Okay, I know because the definition takes time. That's why I told you go to the discussion hour and understand. Okay, this set has an upper bound. So can you answer, Lekha, Shri? Is this set bounded
Yes,
above?
sir.
Is this set bounded
Yes,
above?
sir.
Very good.
Yes, sir.
So I'm clearing all your feedback. Now I'm writing another set B. Okay. Look at, give some examples, then only you'll be able to understand. Okay. So my set is this. Okay. Let's take minus n and in here. Is B bounded above? What are all the elements in the set? All of you know, right? Quick, quick. It should not take time. In fact, we are overdoing revision. We have to go for today's thing. Quick. If it is bounded above, say yes. If it is not bounded above, say no. See, if you don't understand the set, try to write down some elements of the set. Okay, what are all the elements of the set? Yeah, I'll just ask Safia. R5 Safia. Quick, can you give an element of the set?
-1,
Very good.
-2,
-1, -2, -3. Very good. Excellent.
and 3
How about 25? Is it an element of the set?
No, sir.
Very good. Good. That's
My-
it. That's the way to understand. Okay, good. Very good one. But only why only 32 answers? Subika, Lekha. Okay. Tamil lot of people are not opening. Open, please. Udaya Chandrika. Okay, Udaya Chandrika, R3. Can you say whether the set is bounded above?
Yes, sir.
Why? Yeah, quickly answer. No, we are waiting for your answer. Do you know the reason?
Because
plot
it
plot
contains
No,
-1.
-1, -2. The elements are marked like this, right? Yeah, very good. You are telling something. What is it? You are telling -1. Okay. What is -1 for this set? Ray Chandrika, please speak.
Sir, I don't know, sir.
But you said -1, no? Okay. See, that's what. See, it takes time. Go to discussion hour. Maybe if you're not understanding, as I said, call us. We'll have a special class for those who are having problem. Okay, somebody from R7.
Aarti,
Sir.
Is this set bounded above? Quick, hit the bullseye.
Yes, sir.
Aarti,
Yes, sir.
why? See, when is a set bounded above? What should I find for that set? If I want to say it is bounded above, what should I find for that set? Aarti,
Sir.
the definition says this. I have to find. Okay, let's go for. See, you are reluctant. See, the thing is, you know the idea, but you are R5. I think I have asked R5, but anyway, somebody from R5. Kavipriya.
Yes, sir.
Is the set bounded above? If so, why? If not, why?
Yes, sir. Bounded above.
Okay. Why do you say it's bounded above?
Because the elements is less than -1.
Elements are less than or equal. Don't say less than -1. -1 is also there in the set. So
Yes, sir.
-1 is less than or equal to -1. Correct?
Yes, sir.
Yes. Right. So -1 is what then? For this set, what is minus 1?
Upper bound.
Appa. So the set has an upper bound. So if I want to write bounded above, simply how one says in English, A is bounded above if A has an upper bound in R. A is bounded above if A has an upper bound in R. Has an upper bound in R. Just I have to check whether the set has an upper bound. Okay. Another thing is you have to understand what is the meaning of upper bound. Okay. Every member of the set should be less than or equal to alpha. Then I say alpha is upper bound. Okay. Anyway, go back. I think you have to take time. You have to pinpointedly discuss these things in the discussion hour. Okay. Okay. Now let's take the definition of bounded above. I'm going to. Somebody said no. We'll ask them also. Malati, are you clear now?
Yes, sir.
So tell me, is this set bounded above?
Yes, sir.
Very good. Okay. So I'm clearing all your feedback. Now let's look at the definition of bounded above. What is bounded above? Let's take the second thing. Okay. Right. So what is the statement? A is bounded above in R. Okay. If there exists alpha in R such that for all x in A, x less than or equal to alpha. Okay. Let me call this as statement 1. How many of you know the negation of this statement? How many of you can negate it now? Quick. How many of you can negate this statement now? Very good, but still I could see lot of still push. Okay, I'll ask one of you, quickly do it. Somebody from R2.
ಶರೀಫ್ ಅನ್ಸೂಯ
Sir,
Hmm.
A is not bounded above in R
Hmm.
if for any alpha belongs to R,
Hmm.
there exists x belongs to A such that x is greater than alpha.
Very good, fantastic. Very good. I'm clearing the feedback. Okay. I hope you can negate, but do not just do by symbol, understand the meaning of what you are doing. Okay. Of course, take an example. That for that, you take an example of a set which is not bounded up, right? Something like that. But now I will write something. Okay. This is what usually happens. I don't want negation. I'm going to write statement 2. What is my statement? I'll simply write, okay, something. A is bounded above, same thing I'll write. Usually my students do this sort of, okay, this thing. Okay, if I'm going to write something. For all x in A, there exists alpha in R such that x less than or equal to alpha. Do you understand? All of you know what I have done. I have just interchanged the order. Okay. I'm not changed anything. This for all I have put first, and then I have said there exists alpha in R. Okay. Now, is the statement S1 and S2 are same? Or are they different? That's my question. Is S1 and S2 same? Some 20 minutes, seconds. If you say the statement is same, put yes. If you say these two are S1 and S2 are different statements, put no. Yeah, quick. You have to push up. But there is an idea. Okay, go by the idea. Very good. It's a tough fight now. Oh, slowly some party. The red party is trying to win. Oh, good. There is a fight. Wow. Very tough elections, right? Very good. So, good. Push it up. I can give another 10 seconds. So, totally 43 answers. Yeah, do not worry. You can change your party also. No, nothing. No law of prohibition and all. But try to understand. Okay. So, how should we declare which one is right? The same statement. 21 of you have said they are same statement. 24 of you said it's wrong statement. So, can we declare by majority? Okay. Can't do, right? Because it's logic. All of you understand that. Okay, let's ask one by one. Let's ask somebody who is telling these two are same. Okay, let's ask. Let's go to R6 and let's ask who has said yes.
Angeline.
Sir, we just changed the order of writing.
Therefore, meaning doesn't change. That's what you want to say, right?
Yeah, yes, sir.
Or just change the order. So meaning is not changing. So both are same. How do you conclude the meaning is not changing? The idea is not changing. Meaning means idea here. Idea is not changing. Go through, revise. Okay, that question should come to all of you. Oh, now it's tie, right? 22. My God. Great. So, right. So let's go again and ask somebody who has said yes.
Kaushik.
Yes. Kaushik from R7, right? Oh, I'm sorry. You asked Kaushik, right?
Yeah, Kaushik. R7.
R7.
Yes, both the same because it concludes the same meaning as bounded above condition is that x is less than or equal to alpha.
Okay.
In first statement, there exists a particular value, but here in second statement, for every x value. So I think it's same.
But you have to go through. Still, there is some. See, that's not a valid argument, no? Still, you have to convince. Okay, let's now it's time to ask the one who has said no. Okay, let's go to some other group, possibly R9.
Shalini. Malati.
Sir, A is a subset of R.
Yeah, that's fixed.
When we,
Already fixed. Those things are fixed.
sir, if we change the order, the meaning should be changed, sir.
Why? Can you explain why?
Sir, in the first statement, there is a alpha belongs to R.
Yeah.
It should mean the x is less than or equal to alpha.
Same thing here also, x less than or equal to alpha. Explain. Yeah, maybe language. See, you are unable to say in the correct way in what you are thinking, but tell, somehow you tell, convince us why you are saying it's different.
But in second statement, by every x belongs to A is in the first. Then how we cannot say it is the same, give same meaning.
Very good. Why? You have to, that's where you have to say. Okay. You go to the statement and say it is not so. Go to the statement and prove it. Prove. Suppose I give an x, what you have to do? I have to find an alpha, right? With the x less than or equal to alpha. Can you do? That's what all of you should think. I'm clearing all your feedback. I'm happy with the good responses. But now you think, suppose I was started with the x in A. Can I get always can I get an alpha such that x is less than or equal to alpha? If you have not understood my question, put, I have not understood. Put a, what to say, hand symbol. What's my question? Go through the second statement. I start with some x in A. Okay. Can I find an alpha such that x is less than or equal to alpha? Is it always true? Irrespective of what A is, I don't bother. Let's take A to be natural. If you don't understand, let's go with some examples. Let's take A to be natural numbers. Okay, I'll start with 1 in A. Can I get an alpha in R such that 1 is less than or equal to alpha? I'm clearing all your feedback. Okay, think now carefully. A is set of natural numbers. I have started with 1 in A. Correct? 1 is a natural number. Now, can I get an alpha, a real number, such that that particular one, I'm talking only about 1. 1 is less than or equal to alpha. Is there a real number like that? So, let's draw a picture. 1 is there somewhere here. So, now, okay. So, these are all natural numbers. I don't want to draw other natural numbers. I'm looking only at 1. Can I get a real number such that 1 is less than or equal to that real number? Yeah. So let's ask someone. I think, yeah. Epsiba, R3.
Yes, sir.
Hmm.
So you can get a real number which is less than 1, sir.
Yeah. Which one? Less than
So
or
it
equal
may
to
be,
1 I want.
it can be also 1, sir.
Yeah, excellent. Excellent. That's what. I can choose 1 itself. I can choose 2 also. I can choose 3. Yes or no? Yes. For 1, I'll choose 1 as Epsiba is telling. I can choose 2. I can choose 3. Anything doesn't matter. For 1, I'll choose 1. For 2, what should I do? Is there an alpha such that x less than or equal to alpha? Yes, I'll change. Okay. I'll take my alpha to be now 2. Is the point understood? So, if x is 1, my alpha is 1. If x is 2, my alpha is 2. Because I want only given x, I have to find an alpha. We have done this sort of exercise yesterday itself. Everly, okay. Or there exists some, this actually depends on this. Do you understand? So depending on, so general thing, have you understood? If given x, can I take alpha to be equal to x? Yes. So therefore, if I make this as a bounded above definition, every subset of R will be bounded. Do you understand? I'm clearing all the feedback. Therefore, there is a big problem in the second thing. It's completely changing the meaning. If I give second as a definition of bounded above, then you take any damn set of subset of R. Set of natural numbers is bounded above. Set of integers, set of real numbers, any set is going to be bounded above if I give this as a definition. Therefore, I have written something wrong, the definition. What is it? This is because I have changed the order. So now look carefully. So here, if you go, you understand, because this alpha is changing with the x. Okay. But here, what is that I'm telling? Here I'm saying I will find a common alpha which works for all x. That's how you have to capture the idea. This statement says, I can find a common alpha such that given any x, x is less than or equal to alpha. Here it says, given x, find a alpha depending on x. Okay, right. Let's take a plain example and try to understand. Okay, let's make a statement. Okay, our favorite statement. Let's, for every human being, let's even write symbolic form. Okay, H is set of human beings. Okay, I'm going to write like this. For every x in H, for every human being, there exists another human being, Y. Such, what is property? Y is the father of X. Biological statement, right? Do all of you understand this statement? Given any human being X, I will be able to find another human being Y with what property? Y is the father of X. Quick, response quick. Have you understood this statement? No problem. There is no pressure. Understand slow. See, if X is Srinivasan, then Y will be the father of Srinivasan. See, if X is my sister, then Y will be same. Okay, father is same. But if X is somebody else, okay, not from my family, okay, then Y will be different. It doesn't say always this Y will differ for each X, this Y will be different or not. It depends on X, that's all. Depending on X, I will be able to give Y. Okay. If X is Rahul Gandhi, all of you know what is who is Y, right? Like that. Have you understood this thing carefully? Right. But still see, I could see what happened to Dirgha Darshini Kannan? Why you are not, if you are not understanding, put no. How about Agatya Lakshmi? Densil, Dhanraj Prasanna, same problem. I couldn't see responses. Okay, good. Now we'll try to interchange the statement. Okay, this is S1. Now I'll write what is S2. What is S2? There exists Y in H. With what property? For all X in H, Y is the father of X. Same statement. Just I have changed the order of the quantifier. Now look at the meaning. What does it say? Okay, it's a problematic statement, right? What does it say? I will be able to find a person Y such that given any person, given Srinivasan, given Rahul Gandhi, given one of the G4 participant, Balakumaran, Divya, whosoever may be my X, Y is going to be the father of X. Just like father of nation. Yes or no? A common father for every human being. Have you understood the second statement? Okay. So if we interchange, there is a big problem. The meaning completely changes. So I'll give you 30 seconds time. Okay. Try to understand. If you have understood, say yes. If no, no problem. Without any hesitancy, put no. But do it after 30 seconds. Try to ponder over. The first statement is biological, very natural. Depending on X, I can find the father of X. That is okay, right? The second statement is philosophical, right? It's not practical, right? One person being father of each and every human being is completely impossible, right? So, good. So same thing has happened here. What has happened here? So the first thing, okay, bounded above definition, it says you should find a common bound. Okay, alpha is some number which works for all x in A, but you have interchanged the quantifier. So this becomes completely wrong. Okay, then if I give this as a definition, any subset of R is bounded. Why? I'm proving. Take any A subset of R, give me x in A. Then I'll just choose alpha equal to x. Right? So this should not be done. This quite often we do. We simply interchange, okay, without thinking. Okay, just like playing, jumbling, we will interchange. So this says actually. But there is a occasion, sometimes it may not change the meaning, but there is a danger. Okay, so therefore, that's why hereafter practice writing quantifier first, its underlying set first, then whatever is the property, write in the bracket. Okay, very good. I am happy. Okay. Let's go to our group example also. Quickly we'll do that. Okay. What is the identity statement? Additive identity, can one of you say? Under addition. Okay. Additive identity property. Quick. Just recall. Be ready quick. Okay, I'll ask one of you from R8. Devashri. R8, Devashri.
Yes, sir. The exists 0 belongs to real number.
Very,
For all A belongs to R, A plus 0 is equal to A.
very good, excellent. Very good. See, here look at this. There is a common 0 which works for all real numbers. Okay. Have you understood? Right. Let's look at this statement. Statement 1, statement 2. Let's look at additive inverse statement. Can you say, Devashri, can you say what is additive inverse statement? Devashri?
Sir,
Additive inverse.
for all A belongs to R.
Very good.
A belongs to R. A
There exists. I will help you. There exists.
B.
Belongs
There
to
exists
R.
B belongs to R
With what
such that
property?
A plus B is equal to 0. Very
good. Fantastic. But look at this. Okay. When A is 5, what is your B? Devashri, don't answer. All of it's for all of you, right? To think. When A is 5, what is B? Quick responses. Yeah. Now R3. Denzel Joshmi.
Yes, sir. -5.
Exactly. Okay. That's what you got to see. So 5 minus 5. When A is minus E, B is going to be E. Have you understood? Depending on A, I have my B. Okay. But still, there are so many other things which you have to understand. Actually, it's a minus is a notation, but carefully understand. Okay. Now, what you have to understand is depending on A, this B changes. Have you understood? Whether all of you have understood? Right. Very good. So go back to your discussion hour and understand this statement. Try to interchange the order and see why it completely, which one of them has a problem, why it completely interchanges the meaning. Can I interchange here? Can I interchange here? Ask questions. Okay, so be careful while writing. Okay, while saying the order. Excellent. Okay. Fantastic. So, discussion hour exercise. Discussion hour. Change the order and see whether the meaning changes. Okay, whether things change. Right. Now let's go for one more example. Okay, let's do an example, something like this. Let's take a statement. Okay, and see. Okay, now I'm going to clear all the feedback. One more thing which we have to do. Other things, just your one more important thing about this quantifier is still pending. That we will do now. Okay. All right. Now the thing is quick commutative property under addition. I want one of you to say quick commutative property under addition with proper quantifiers. You see others, R9 Akhilandeshwari, what has happened to you? Now you have responded. Satyabala, Saumika, Tamilarasi. You could find Tamilarasi having some problem. Let's check. Kavipriya, what is your problem? Somebody has put some other symbol. You can change it, right? Okay. Yeah, somebody from R2. Which group I didn't ask today? R4, right? Somebody from R4. R4, Agatya Lakshmi. Agatya Lakshmi?
Yes, sir.
Quick.
Yes, sir.
Problem with your mic?
Yes, sir.
Okay, Agatya Lakshmi, you're having some problem. Oh, you are having some problem in the mic.
Sure.
Now you speak.
There exists A, comma, B,
Oh,
comma,
no.
C.
Is it there exists? Okay, you think, carefully think. Let's go for R7.
Harini,
Sir,
Yeah.
for all
Uh,
A comma B belongs to R, A plus B equal to B plus A.
Very good. And what is its negation? Quick.
There exists
Hmm.
A comma B belongs to R,
Hmm.
A plus B is not equal to B plus A.
All of you know this, right? Given A, B in R, given two elements A, B in R, always A plus B equal to B plus A. When it is false, I can find two elements A, B in R such that A plus B not equal to B plus A. Right? Okay. Now let's try to see. I have simply taken comma. Okay, what is the meaning of comma here? And so let's rewrite this statement yes carefully. This is absolutely correct. But now let's try to expand this. Somehow we will land up in some problem. I'll tell you where. Okay, that's the point. See, I will put and, right? Two things. For every A in R and for every B in R, A plus B equal to B plus A. Okay. But when I negate, what will happen? If I negate, all of us know, right? What is the negation? There exists A in R or there exists B in R with what property? A plus B not equal to B plus A. Okay. Same statement I have written here, but these two negations are different. Here, this is absolutely or only itself, but here it says, again expand comma. What does this say? There exists A in R and there exists B in R. So the negation says, here it says both A and B. Here it says one of them. So I have a problem, serious problem. Okay. So where is the problem? So for that, let's not think like this. Let's go for an easy example. Okay. Very natural English example. I'll simply say, for every boy and for every girl, okay, there is a marriage bureau. Say in Mumbai or Chennai, somewhere, which finds a match for them. Okay, the right negation I know, right? What is the right negation? There is a boy and there is a girl, such that given any marriage bureau of Chennai, they will not be able to find a match. Okay, again, same problem. Okay. So, how should I get rid of this? Okay. So, can any one of you think about this? Just 10 minutes, ponder over it. Then if you don't get, no problem. I'll explain where the problem is. Have you understood where the problem is coming? What is the correct negation? The correct negation is, for every, there exists a boy and there exists a girl. There is a boy and there is a girl. That's the correct negation. There is a girl. Okay, such that given any marriage bureau of Mumbai, okay, they will not be able to find all these things. You can fill it. There is no match for them. They will not be able to find a match for them. Okay. So this is and. But again, if I explain, okay, let's take B to B. Let's rewrite this statement. B to B what? Boys. Okay. Before writing all this, because this will go too technical. So let's ask the question. What is the condition of this marriage bureau? How should we go to him? We should go as a, can I just go with one boy and go to the marriage bureau? That's where the point you have to think carefully. So how should I go to the marriage bureau? Think about this question. If you have an answer, quick, respond. Very good. Some of you are responding. I'm happy. Let's ask Malati. R9 Malati.
Sir,
How should we go to the marriage bureau?
sir, with the boy and a girl, we go to.
Very good. With a boy and a girl, I should go as a pair. Okay. Is the point understood? See, whenever we go, we have a pair of chappals, right? So you should go with two. Pair of chappal is seen as a single unit. So whenever I go, I should go with a boy and a girl. So the correct way is I have to think these two things as a pair. A, B is not just, okay, A, B are real numbers, but I have to go as a pair. So for pair, what is the right thing? Okay, I have to use this. This is ordered pair, right? B, G. Okay, so the original statement is, let's keep B for set of boys. Okay, G for set of girls. So what is the original thing? How I should rewrite the statement carefully? The rewritten statement should be for every B, G. Okay, in which is set? Can you say what set it is? Can all of you think? Quick. I'll just clear all the feedback. Ordered pair 1, 2, where it will lie? Or let's say ordered pair 1, okay. 1, 1 itself, where it will lie? 1, 3, ordered pair x, y. It belongs to plane, right? Whatever we draw graph. Yeah. So can one of you say quick, Kubendran, R9 Kubendran?
Sir, B comma G belongs to set B and G, sir.
Not B and G. Okay, R6 Rahul. Again, that's the confusion. That's why we want to get out of it. If I write and, that is the confusion. No? Yeah, Rahul, quick.
Belongs to the plane capital R.
Capital R. What do you mean by capital R? 1 is an element of capital R. 3 is also an element of capital R. Whether ordered pair 1, 3 belongs to capital R? Rahul.
Sir?
You said capital R, right?
Yes, sir.
See, whether ordered pair 1, 3 belongs to capital R. See, 1 is looked as an element here. 3 is also lying somewhere here. Where does ordered pair 1, 3 lie? It's lying here, no? Yesterday I draw pictures, right? All of you know where to draw ordered pair 1, 3. Yes or no? 1, 2, 3. Where will you draw 1, 3? Rahul, quick.
Sir, 1 in the x-axis, 3 in the y.
What is this? So I have
Oh,
x-axis, y-axis. What is this set now?
Belongs to x, y.
R cross R. A cross B. You have not heard of it? Anyway, we'll do it during foundation. That's the purpose of foundation. Okay, usually people call it as R2 plane. Okay, the points, ordered pair points belong to plane actually. Okay, this is the ordered pair 1, 3. It doesn't belong to real. So where does B, G belong to? Where do B come from? Set of boys. Where do G come from? Set of girls. So it is B cross G, Cartesian product. Okay. So I'll write using this for every B, G. So the underlying set is B cross G, not set of boys and set of girls. Okay. B cross G. Now I write condition, I'll get it correctly. For every B, G, B cross G, there exists a marriage bureau in Mumbai which finds match for them. What is the negation? Because the underlying set is correct. I hope all of you will get the correct negation. Okay, I'm clearing the feedback quick. Negation. One of you should say the negation quick. Very quick. I may ask the people who are not responding also. Right? Now somebody from R1, Sanjana will ask. Sanjana, what are you doing?
Sir, please.
Sanjana is speaking, right?
Yes, sir.
Yeah, tell.
Sir, I couldn't get what you say, so I didn't.
You have to ask me. I am asking for negation. For every B, G belongs to B cross G, there is a marriage bureau which finds a match for them. What is the negation? Can you think slowly and tell?
Yes, sir.
So what should be the first? It's layer by layer, no? Already we have written in bracket. Can you start with? What is the underlying set now? B cross G. How elements are written? Ordered G. So for every is there. So therefore, what is the negation?
For every B,
Negation,
G
negation for every?
negation.
Okay. I know. Okay. Now you can think about it. I'll ask someone else. Okay. Let's go for somebody in R6. R6, Subika.
There exists B, G.
ordered pair B, don't say B comma G, ordered pair B comma G belongs to
B cross G.
such that, can you negate?
For every
Very good. For every, you want to see my previous statement, you look at here. There is a marriage. For every
marriage in
bureau in Chennai, they will not be able to find a match for them. For every marriage bureau, I think this is not going to be a problem for it. Bureau in Chennai. If it is so, then clear it. Okay. During discussion for every marriage bureau in Chennai, they will not be able to find a match for ordered pair B comma G. Okay. So I have to go as a pair. That's why we have put this B cross G. Now let's go to the commutative thing. Okay. Look at the statement now. So for every A comma B in R, A plus B equal to B plus A. Now how should I rewrite this statement? The original statement itself I have to rewrite. Okay. Call it as S1. How should I rewrite? For every ordered pair A comma B, can you continue after this? I'm clearing all your feedback. See, why that confusion arised? The confusion arised because we have not understood the underlying set properly. We have put a comma, but that comma means and. But if we write with and, the negation, there is a problem. It comes as a or. So we are confused. But we know from idea, the correct negation should be only and. There exists a pair only. Because now, why the problem is, in the original thing, we are not seeing it as a pair. So what we are saying is, see it as a pair. So that's all. It's very simple. Understand it from the idea. So even though here it says A comma B, two real numbers, actually we want to see it as a pair. Therefore, I'm putting it. Okay. Now I have already put a pair. So tell the underlying set properly and tell the property properly. Okay. Have you understood? Still see, I could see only 25 or 26. It's a problem. Because you are not concentrating. Please pay attention, concentrate, and make use of the program to the maximum extent. Okay, R5, Dirgadarshini.
R cross R.
Very good. Yeah, complete the sentence. For every A comma B in R cross R. Yeah, what should I write here? Same property, rewriting only, no? A plus B
equal to B plus A.
Right. Oh, sorry. Here I have not written properly. A plus B equal to B plus A. Here it is B plus A. Right? Now look at the negation. Dirgadarshini, can you say what is the negation of S1?
There exists A comma B belongs to R cross R such that A plus B not equal to B plus A.
Can we expand further? English meaning? What does this say? A comma B belongs to R cross R means what? There exists A in R and
B in R.
there exists B in R. Correct? Such that A plus B not equal to B plus A. That's what our original thing is. Therefore, we have put a comma. There exists A comma B in R such that A plus B not equal to B plus A. Therefore, it tallies with our original intuition. Already, see, in the mind, we already looked it as a pair. Therefore, we got the negation correctly. Okay. But when somebody asked it to comma, if I have, I should put and. If you do like that, then the thing is here, we are not writing the underlying set properly. If I break it, I have completely spoiled the underlying set. Okay. Somewhere I have written. Where is it? Back here. So we are spoiling the underlying set. Okay. This is not the underlying set. The underlying set is R cross R. Because A belongs to R, B belongs to. Okay. I'll clear all the feedback. In fact, all the other properties, associative, okay, all these things, do it during the discussion hour. Let me give one more statement. Okay, quick. So you do this for every real number, for every positive real number x, and for any real number y, number y, in fact, maybe I'll put it here, for any real number y, of course, there exists a natural number n in n. I'll write all this simply. There exists n in n such that nx greater than y. Okay. Can you rewrite quickly? First of all, what is the quantifier and its underlying set? Same question. I want to write the statement in symbolic form, no negation, nothing. First, I have to write the statement in the symbolic form. Okay. First of all, tell me how many quantifiers are there. This is where you have to think carefully. Very good. Still people, I want people to push. Already we have done an example, right? It's in the same pattern for any positive real number x and for any real number y. So it doesn't matter which way I come. Their order doesn't matter. Any real number y, any positive real number x and any real number y. So what it says is give me two entities. One is positive x and real y. Then I promise you with something. There is a natural number with some property. Nx greater than 1. Okay, good. Now I'll go and ask, but still I could see a lot of people are having problem. Go back to discussion hour, discuss. I could see only 37. Yeah, somebody from R7.
Soumya.
For all x ordered per x, y belongs to R cross R. There exists
No. Go. I don't want the property. See, first I asked you only quantifier. Which quantifier? How many
For
quantifiers
all
are there? How many quantifiers?
2.
Okay, don't, okay, 2. Very good. 2 means what? What is the first quantifier?
For all
Second
there
one?
exists.
There exists. Very good. There are only 2 quantifiers. See, here it looks for every positive real and for every real one. There are no 2 quantifiers. There is only one single quantifier. Very good. So ordered per x comma y, where does it belong to? Now you have to be very careful, Soumya. X has to be not any real number. X has to be
Positive.
So you invent a new notation, okay? So take R plus, right? We'll define what is R plus. R plus is set of positive real. We'll define colon equal to set of all x in R such that x is positive, right? So now you complete R plus.
Cross R.
Very good. R plus cross R. With what property?
There exists n in n.
Right.
Nx greater than y.
I'll clear all your feedback. Have you understood what Soumya has done? Okay, how it is rewritten. The point is quite simple. Don't see it complicated. Okay. See, in English we are saying for any positive real x and for any real y. Right? Actually, what we mean? Take a pair xy. First x is positive and y is real number. Given a pair xy like that, then I promise you something, some property. Okay. So therefore, for the first quantifier for every, the underlying set is R plus cross R. That's what you have to understand. See, in discussion hour, go back, do commutative property, do associative property. You will understand what is the underlying set there. Everywhere the underlying set will change. Then you know how to write it properly and negate it also properly. Okay. Quick. From this group itself, I'll ask one of you to negate. I hope all of you will negate correctly. Sophia, R5. Or anyone.
For
Right. Start.
there exists x ordered pair of x comma y belongs to R plus cross R for all R plus cross R for all n belongs to n, nx less than y. Less than or equal to y.
Very good. Excellent. For all n in n, nx less than or equal to y.
Less than or equal
to y. What is the English meaning of this? Again, if you expand, what will happen? Expand again. There exists
x belongs to R plus and
y belongs
there
to
exists
better.
y belongs to
R. Such that for all n in n.
For all n in n. Nx less than or equal to.
Great. Okay. Good. So that's the thing. So better do carefully with the okay underlines. Okay. Now let's take a statement. We'll try to, like yesterday, we'll do a statement. It's going to be big. I think now you are going to be experts. That's all. All the things are over on quantifiers and this thing. Only thing is practice is required. Formulate as many sentences as you can and try to negate it. Okay. Now today we'll do an exercise. Okay. In every city, India, in every city, there is a, okay, let's start with a state. In every state of India, there is a city in which given any street, there is a house in which every member has got PhD in mathematics, maths. Okay, let's write maths only, short, maths and economics. Okay. See, the statement looks very, very big, okay, with a lot of thing and all. So first, what we have to understand, I know some of you can even negate without writing all the symbolic form and all, okay, but let's be systematic, okay. Let's do that clearly, but caution has to be there. I have to write carefully. So first identify how many quantifiers and their order properly. Quick. You have to say in that order. Just to say what are all the quantifiers in that order. Quick. So we are almost closing time. We can continue this example, the discussion or also. First, try to understand what has been done so far. Don't take this first. Okay, do it later. Right, very good. I'm going to ask R8, Aditi Verma. Quick. Aditi Verma.
Yes, sir. Totally 5 quantifiers. Sir.
Very good. What is the order?
Every for all there exists.
Good.
For all.
Very good.
There exists.
Good.
For all.
Very good. Excellent. Okay, that's it. Okay. Now we'll pick up. Do this during discussion hour also. I'll do only first two for you. So what is the underlying set for the first quantifier? Akhilandeshwari, R9 Akhilandeshwari.
Set of states in India.
So shall we'll keep yes, right? Set of states in India. Good. Second quantifier, Akhilandeshwari, you should say.
Set of cities in
No.
state.
Very good. Set of cities.
In state.
In which state? That's where you have to be careful.
In state, yes.
No,
sir, small is.
Small s. Very good. So given small s in yes. Okay. Now I have to write set of cities. We'll call it as CS. Set of cities in state yes. Okay. Don't complicate. Okay. Third thing, do not complicate with so many subscripts. I'll do the third thing also. So two quantifiers, we have finished the underlying set. For third quantifier is for every. What is that for every? Which there exists? Any street. Okay, this is the third one. So we will simply write set of all streets. We'll use T for streets. Okay. So T, because already yes, we have used. So maybe T for, okay, of the city TC. That's enough. Don't put so many complications. Okay. So given a city in CS, TC is what? Set of streets in C. In the city C. Of course, the city C, which lies in CS. That is there actually. Okay, right. That's fine. C smallest. Okay, I hope you can complete this, right? So I want to leave it like this. We'll see during discussion time. If you have a problem, we can discuss it during the next class. I hope you can do it, but take it in the last. First, complete what we have done so far. The 2 points we have emphasized. Okay, one is about the order of the quantifier. Second one is about writing the underlying set properly. Okay, yeah, I'll stop here. Divya?
Yes, sir. So, thank you, YouTube. Thank you, YouTube viewers. We'll meet on 25th October.